Okay, I guess I'll start. It's 10 o'clock. Although it says 9 o'clock on my laptop, being, as you can hear, British. I've worked out why NDC now give you these really nice warm sweatshirts. I've not been to Norway in the fall before. It was 25 degrees when I left London, but not today. So I'm thankful. I normally just put those in for my, for painting, but no, useful. Thank you all very much for coming. I'm going to be talking about this subject, microservices and the inverse Conway manoeuvre. This might be quite familiar to some of you, but I'm going to hopefully unpack in quite a lot of detail what I think this means and what it means for software development, and for how we structure our teams. So whilst much of this conference is about low level, this is 10,000 foot. This is a little bit higher, taking a bit of a higher view on the sort of job we do as developers and the organizations in which we work and the teams in which we work. So this, I guess, is my hypothesis. Essentially, that software boundaries are isomorphic with organizational or team boundaries. And because of this isomorphism, we can reason about properties, characteristics of our software by reasoning about properties of our teams. And I'll talk about which sort of properties, but essentially things like time and distance, of how far our teams are away from one another, affect actually how we write our software. This was controversial, has been controversial for a number of years, but I think we've come to a place now where we kind of understand that this is a thing. I should introduce myself first, I guess. So I work for a company called ThoughtWorks. Who's come across us before? There's a couple of people in the room. Okay. So that's good. I'll explain who we are. Up until last week, we were a privately held bespoke software development company. We do all forms of software development. Normally, people don't talk about using our services because we're normally called in when things are on fire, basically. But whether that's very low-level stuff, so firmware for robots in warehouses doing picking, up to your more basic web e-commerce-y stuff, we pretty much do all of it. So we've been going about 25 years now. There's about 5,000 of us globally. I've been at the organization for about 12 years. I still love it. We'll see what happens with the acquisition. We're now held by a private equity firm. So we'll see. If you've been through an acquisition before, I'm sure you'll understand our nervousness. Anyway, so that's who I work for. I'm a consultant then, so, woo, consultants. Everyone loves a consultant, right? Yeah. If you haven't heard of us, you might have heard of some of the things we've done over the years. So we're really passionate about many things, diversity, but also sharing information, sharing what we've learnt on our projects. So we're a fairly pragmatic bunch, and we like to share what we do. So these books are all published by either current or ex-ThoughtWorkers, which is what we call ourselves. And obviously some of these are canonical in the realm of what we do. So if you're going to be doing messaging, that's the canonical book in messaging. Building microservices, a canonical book on how to design your code through testing. And a bunch of open source projects, including arguably the first continuous integration server, Cruise Control. So that's us. This is me. I had the fortune, I think it's good fortune, to go and hang out for a week at Martin Fowler's house to write this article. So the name existed before we wrote this article, but if you look at the Google Trends, if you look at the Google Trends results for microservices, it sort of takes off after we wrote this. So we've sort of put together the first definition of what a microservice is. So on the one hand, awesome. On the other hand, we're really sorry about that too, because it's now a multi-billion-dollar industry. You can buy microservices by the handful, buy 5 and get 5 free, that sort of thing from IBM, so on. So I'll be talking about some of these characteristics, and I'll come to that in a moment. But first, I'm going to define, or rather state, in brief form, what Conway's law is. So this is what Melvin Conway said back in 1968. He said, organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. This is the isomorphism piece, right? It's an information theory thing, it's a bandwidth thing, it's a coupling thing. The higher the bandwidth between people in an organization, essentially the more tightly coupled the software that they are creating is going to be. Now think about that, because that's quite profound, actually. It's quite a profound statement. We can reason about the coupling of our software, the cohesion of our software, based on bandwidth of communication between our teams and the locality of where they sit. Interesting stuff. He said this back in 1968. It was initially, the paper he wrote was initially rejected by the Harvard Business Review for being unproven. More research required, I believe, was the exact sort of phrase that was used. So because of that, and because it's 1968, I've got this feeling in my head of Melvin Conway sort of sitting there laughing at us at this point, right? Because this has been decades since he came up with his law. So I think of him as like one of these Muppets in the Muppet Show. They're sort of sitting on the balcony laughing at us. Right? Fast forward a couple of decades, and MIT and HBR put together another piece of research exploring whether this is an actual effect, an actual thing or not. They called it, the snappily titled, Exploring the Duality Between Product and Organizational Architectures, a Test of the Mirroring Hypothesis. And they looked at hundreds of organizations, hundreds of bits of software, ranging from very large enterprises, closed source, to lots of open source pieces of software. So that was the sort of scope of the research they did. And essentially they found what I've called out here. It's a bit unclear, so if I'll unpack this a bit. What they found is tightly coupled organizations, design becomes more tightly coupled. But with loosely coupled organizations, architecture is more modular. I think this is, again, this is interesting. It's reinforcing what Melvin Conway said in 1968, that depending on the bandwidth between teams, depending on locality of teams, where you are in time and space, essentially, your software will either become more modular or less modular. Do we want modular software? Who would like to have modular software? Right. Who would like to have, well, cohesive software is another way of stating that. Decoupled software. I'd like to have my software to be decoupled so that I can change my software independently of other teams, other bits of software in the organization, which is a fundamental, that's actually pretty much a statement of the single responsibility principle. The single responsibility principle says software should have a single reason to change. So these are the characteristics Martin and myself called out when we wrote about microservices, defined them. Most people look at, I might just like to see if this works. Ooh, yeah. I normally get gasps from the audience. The first time people see that, how cool is that? Most people seize on componentization via services and say, well, this is just service-oriented architecture, but for the millennials, right? This is just a woke version of service-oriented architecture, using my 16-year-old daughter's slang here. But actually, we called out many of these characteristics, and what we sort of state is the organizations that we were seeing being successful with a microservices architecture, and actually this ranges from the Netflixes through to the Guardian newspaper to the Twitters, but also actually I was in Eindhoven, when was it? A few months ago, teaching a class on microservices to a bunch of embedded software developers, and actually the thinking resonated very much with them as well. That's not my world, I should point this out. I'm a bit higher level than that. People pick up on componentization via services, but actually all of these were what the organizations who were successful were doing. They were doing all of these things. And the things I'm going to talk about today really focus around two. This idea of organization around business capabilities, or business functions, I'll define what they are in a moment, and how we actually build our project teams, or rather product teams, in the new world. I should answer a question. I mentioned service-oriented architecture, but for millennials. How big are they? Right? And if a traditional service, this is how I explain it to our salespeople. when they're trying to sell the 5 of them and then get 5 free and that. If a normal service is about this big, then a microservice is about that big. So that's all clear, right? You can all answer the question, how big should a microservice be?
How long is a rope?
Yes, actually there's a good, how long is a rope? There's a really good, it's about 3 foot. So do you know the story about Grace Hopper? This is a lovely story. So Admiral Grace Hopper was one of the, she wrote the first compiler, right? She was a naval officer in the US. Amazing woman. But she took to carrying a 3 foot bit of rope around, because she'd go into all these meetings with admirals, with other admirals and other high chiefs in the Navy. It was just at the point where radio communication was able to essentially span the world, so they could distribute orders globally to all of their warships around the world. But of course, they couldn't quite grasp why, when I give an order now, it takes some time for someone in the South Pacific to actually pick up the order, right? They couldn't grasp why it's not completely instantaneous. So she took to carrying a 3 foot piece of rope around, which she used to say, this is a nanosecond rather. So she described nanoseconds in terms of a 3 foot bit of string, and she would say, if it's going to take so long to get to the other side of the world, and this is how far light travels in a nanosecond, you can work out why you've got a delay, right? Because you need lots of these 3 foot pieces of string to get to the Pacific, which I thought was a really smart thing. So anyway, that's how long a microservices is, or something, how long a piece of string is, 3 foot. So the promise of microservices, right? Why do organizations try to build microservices or adopt this technology, this style of architecture? This is the quote from Adrian Cockcroft, who, when he was VP engineering at Netflix, and that he's now, I think, VP for AWS, VP engineering for Amazon Web Services. So he's a fairly serious individual. And he described their adoption as because they wanted to go as fast as possible. So this is the promise, right? We want to build stuff that's cheap to replace. We want to be able to scale things quickly. We want to be resilient in the face of imperfect networks. The internet is not a 5 nines fabric, after all. We all know this. Unless you're Google, in which case maybe it is. We should be able to go as fast as possible. So why is it that many organizations can't? I'm going to unpack that now. So this is a sort of amalgamation of many companies that I've been in over the years, but it's a fairly accurate picture of many of the places I go. So this is kind of how people tend to organize, right? We organize into these functional, role-based or technology-based silos. And we do this for various reasons, mainly cost efficiency. It feels as if we should organize all our developers together, our architects together, our project managers together, our testers together to create centers of excellence for cost efficiency purposes, right? We have these different silos. Now, stepping back a bit, one of the things I think every software developer at one point likes to build visualization tools to understand what their code is doing. So this is an example of one I built. It's a very simple one. It's looking at Spring, if you know the Spring framework. This is the dependencies of the Spring framework. All the separate libraries plotted on something called a chord diagram, hierarchically edge bundled chord diagram where you've got the links denote dependencies, efferent or afferent couplings on each of the libraries, right? So it's a pretty typical visualization technique showing what things depend on what other things. Now I had a thought when I was doing this. We can do the same thing for organizations, right? Isomorphic teams software. So if you do that for these role-based silos, what do you get? Well, you get this dependency map, this chord diagram of teams depending on other teams. Maybe this is, you think about in your own organization, in your own organizations, you could do something similar. And you can imagine, what happens here, where sales get really excited, oh, there's this new feature we need to build. A new feature needs to get developed because this customer has asked for it. Okay, well, I'll go to the project management office, I'll write my business case, I'll get it approved, I'll go to the PMO, I'll say, I'll need a project, I've got an approved business case for $1 million or whatever it is. And the PMO say, well, okay, well, we'll schedule that for a project at some point. We'll get some developers together, so they get a team of developers together, and then they hand the requirements to the architect. The architects do some design, then they hand it over to the developers. The developers do some development and then say, Here we might need to change the designs because the laws of physics or something. They hand it back to the architects, and then it goes back to the developers, and then to the testers, and so on. It's a fairly standard approach to running projects in many organizations that I see. As you can see, this work essentially, the implication here is work is flowing. Work items are flowing around this chord diagram across these chords. I mean, there's another sort of approach to do, and this is a fairly standard sort of way of plotting how work flows in an organization. I like this because we've got roles down here, we've got time on the x-axis. That's where work is done, right? That's development. That's those poor people just typing, the monkeys who do the typing, right? Development. Well, this is another way of plotting this linearly. If you've come across a value stream map before, put your hands up if you've seen a value stream map. Okay, I'll explain this then, because I find these are the most useful way of understanding how work works in organizations. So what a value stream map shows you is how long it takes to get stuff done. So if you imagine a single requirement starting this end, an idea, and this is a real one from a real company, redacted obviously, requirement hits a team, it waits in a queue for 2 days until someone's free to pick it up. For 3 days someone does some design on it, or actually in this case it was development, so write some code. It then waits in another queue for 10 days before a tester picks it up, 1.5 days of testing. It then sits in a queue for 30 days waiting for deployment, right? And then finally it's deployed and we're earning money. That's essentially what a value stream map says. We have wait times on the bottom and we have value-adding activities on the top. So if we're looking at the length of time it actually takes to get something done, a single requirement going through this software development process, we've got, 3, 4.5, 5 days of value-adding activity going on. But it actually takes 5 plus 7, 17, 47 or something days. 47 days to actually get into production, earning us money. Now there is a concept from lean manufacturing called the cost of delay. And the cost of delay is defined as the amount, it's a bit like what you could have won, right? If you'd chosen the right answer in a quiz. It's the amount of money you could have made if your software or if your product was on the market earlier. So in the best case, if you lined all of this up, you could have had your product on the market earning money in 5 days. But you've got 42 days of delay where you could have been making money. And if it was $10,000 per day, you've lost a lot of money if you've got this software development process. This is why I think about software development often as a bit like snakes and ladders, right? You kind of 1 step forward, 2 steps back. You're waiting for stuff, waiting for stuff. So going back to this diagram, I mentioned this sort of represents the flow of work around an organization between different teams in an organization or groups of people. Actually, what each of these chords represent, really, is at least one queue. Queue in the sense of computer science queue, right? A first in, first out ordered queue, queue. What's interesting about queues is, and if you haven't picked up this book, this is probably, I would say, the most important book on what I think we do, written in the last 20 years even. It's not even about software, it's about product engineering. In this book, Don Reinertsen, who's a very interesting chap, he's an ex-NATO submarine commander who became a management consultant, but he talks about the effect of queues in systems. And this is true in software systems. This is true for operating systems. It's inspired by OS design and network design, actually. But it's also true in how we structure ourselves. When you have queues in front of you, you get these effects. And they're not good effects. And they're also not necessarily intuitive why you get these effects. So queues create longer cycle time. It takes work longer to go from the bottom of a deep queue to the top and then to be completed than it does if there's no queue. That's pretty obvious, you'd think, right? So deep queues, long queues, they increase the amount of time it's going to take to get stuff done. They increase the risk that something's going to change while the work is sitting in a queue. So if I'm a developer and there's a big, big queue in front of me of 100 items, and it's going to take me a couple of days to do each one, by the time I get to the last item, the requirements might have changed, requiring me to hand that back to someone else upstream to rework the requirements. They increase the risk of what we do. They increase the risk of building the wrong thing. They also introduce variability into our processes. Essentially, as queues shrink and grow, they mean we can't predict how long it's going to take with any accuracy. Essentially, we get the standard deviation essentially for the variability of our system is massive in a system with growing and shrinking queues. We also get more overhead, right? The more queues we have, the more we have to manage those queues, which means the more meetings we have to have, which means the more time we have to spend in meeting rooms talking about stuff. That's kind of interesting effect, if you think of it, of queues. We also have lower quality and less motivated people. It's much more motivating for me as a software developer if I see my work in production, making money, saving lives, whatever it is, in a day or 2 days, than if I have to wait 6 months for the next deployment because there's a queue in front of deployment. Much more motivating. So you have to have a quote by Peter Drucker in all of these. Any presentation about this sort of stuff, there's nothing so useless as doing efficiently that which should not be done at all. I'll give you an example of what I mean by this and some of the effects of queues in our system. And when I say queues, I mean every time you have to raise a JIRA ticket to get a new piece of hardware, every time you have to raise a JIRA ticket to get something done somewhere else. That's the sort of physical sort of instantiation of queuing, really. I said I'd explain what a capability was. So this is my definition of a business capability. A capability is a combination of people, processes, systems that provide value to customers. And this could be internal value, so internal customers, or it could be external customers. And crucially, it's the what of what we do, the what of what our business does, not how our business does it. It's not the process our business follows to get something done, but it's the big, stable chunks that our business has to do. If I'm in retail, I have to sell some stuff to our customers. Selling to our customers is a business capability. I might choose to sell stuff in varying different ways. I might choose to do it through a mobile channel. I might choose to do it through a bricks and mortar store. But I'm still selling stuff. And if I'm not selling stuff, I'm probably not a retailer anymore. Similarly with delivering things. I have to get the goods to my customers. That might be fetching them from stock in a store and handing them over. It might be scheduling a delivery for a truck to turn up. It might be a drone in the future. The processes by which you implement capabilities change, but the fundamental building blocks of organizations stay the same. Give you an example from ThoughtWorks. I'll show our model later. But in ThoughtWorks, we're a consultancy. We have a staffing function. One of the core things we have to do, core capability, is getting the people with the right skills onto the right projects, to build the right products. Right? That's always going to be the case. There's never going to be a case when we don't have to do that. We might do it in the future through machine learning, but we're still going to have that staffing capability. Finance, selling stuff. Stable parts of our business. This is what a capability is. So going back to organized around business capabilities, which I'm doing it that way. It should be reading that way because you're reading it that way. Organized around business capabilities. This is what I mean. Structuring our organizations around these things, these stable parts of our business. Which kind of makes sense in some senses, right? Because what are these properties we want from software? We want our software to be decoupled. We want our software to be cohesive. Our business capabilities tend to be decoupled and cohesive. So this is the sort of highest level organizing principle, if you like. The problem is when you drill down into these, you start to see issues. When you drill down into different levels of organizational structure. So this is an example from a retailer that I worked with, actually an online retailer selling train tickets. They had this really nice split. By the way, this is obviously a message queue. This is official diagrammatic stuff. It's not really. They had a capability separated by two oceans. One capability in London, one capability in India. One was building the capability for delivering stuff, one was building the capability for selling stuff. And this was kind of cool, but every now and again, they'd start a project to work on these things, and a group of people would pop into the code, and then they'd pop out again. They'd pop into the code as another project started, and pop out again, and they'd pop into the code. And what they ended up with is this nice decoupling across these capabilities, essentially via messaging. But within the capabilities, they had this really tightly coupled software. And this was a function of their team organization on this project level team organization. We start a group of people together, they pop into the code base and then pop out again. No one is taking ownership. No one is actually understanding or having ownership for long-lived parts of this code. You end up with this sort of tight coupling internally. This manifests in a number of ways. I don't know if you've seen this, come across this idea of hardening. Hey, we're going to be agile and kind of cool, right? And we'll do these iterations or sprints or whatever, and then we'll have to stop, and then we'll have to do regression testing, we'll have to do performance testing for 6 weeks, and we'll have to do deployment testing for 6 weeks. This is like all the awkwardness and sort of having to go as quickly as possible of agile with the running into the waterfall brick wall. This is kind of scrummerfall, if you like. This is the description. Yeah. Another sort of effect of this I've seen is fan-in to end-to-end testing. This is where we notice our software, whilst we can work on it independently, has to integrate with our wider system. We can't actually deploy or test things really in isolation all the way through into production. We have to fan in to do some integration testing. So we have this fan-in to end-to-end tests, which means, well, I've got another talk about this, but you end up with all sorts of issues with this. This is the whole problem we have in an organization where you have, I need another integration environment. Oh, well, you can't because they're too expensive. Okay, we'll have to lock this team using the integration environment for this week, and then the week after, this team will use the integration environment, and so on and so on. It's pernicious, the effects of this fan-in. And it actually gets worse if you think about it, if you're building software composed of microservices, smaller components, because you get more fan-in, unless you think about how to break this stuff up. So fan-in to end-to-end tests. Yeah. And then there's this final effect, which is having to deploy everything all at once, which is inherently risky because we end up with a queue. So we'll do some nice iterative process, and then everything will back up and back up and back up and build up in a queue and build up in a queue and build up in a queue. The more change you have in your code base ready to go live, the more risky it is. This is fundamentally why continuous delivery and continuous deployment talks about the optimum being the smallest unit that you can push all the way through into production, because it's less risky that way. So we started talking about this as the distributed monolith. It's, we've broken stuff up into smaller bits, but they're still actually fundamentally deployment coupled. It's a distributed monolith. Marvin Conway's back. He's laughing at us again, I think. So what might good look like? Takes a sip of coffee. Does anyone recognize this? I appreciate I am in Scandinavia, and so asking you questions at this time in the morning is maybe not, it's maybe a little uncomfortable, so maybe I'll stop. This works much better in the US. I'm joking. This is the Ebola virus. All right, this is what it looks like. And this is a lady called Pauline Kafeki. So in the Ebola crisis in Africa a few years ago, 3, I think, sort of, we call them territorial army, but 3 sort of part-time army personnel who were medics went out from the UK to Africa to help out. Actually, incidentally, ThoughtWorks built the, talking of simplicity from the keynote earlier, ThoughtWorks actually built the interface for the hardened iPad that they took in the red zone. Now that's a really interesting UX problem, right? How do you get that stuff to work when people are wearing 3 layers of gloves? The red zone is like, it's the treatment bit where people have Ebola. Then you go out into the green zone going through decontamination. So how do you build software for people with 15 layers of clothing on and kind of masks? It's an interesting problem. Anyway, that's by the by. Pauline Cafferty was one of the nurses who went out from the UK. And when she came back, she had contracted Ebola, unfortunately. This is her after treatment, so she survived, which is great. This is the team that treated her at the Royal Free Hospital in London. So this is the infectious diseases unit, the sort of, I guess, our actually the UK's sort of specialist infectious diseases unit. This is the team, this is the consultant, Michael Jacobs. And I was reading about this in a newspaper, and I've been thinking about Conway's law and organisations. And I was thinking, well, how is it in hospitals when they're treating infectious diseases, especially a disease such as Ebola, right, where you have to treat it, you have to make decisions incredibly quickly and get stuff done incredibly quickly, because you can only support the patient, you can't actually really cure the patient. How does decision making happen? Because if you think about a hospital, I would think the different functional groups or areas within a hospital, pharmacy, finance, microbiology, etc., you'd think they'd have the same issues as we do in software development, right? Where you've got all these queues, I need to get a blood test, fine, it'll go into the blood test queue, and then the people doing blood tests work through the items on the blood test list in their queue. But how does that work for infectious diseases when you have to make decisions like this? And it turns out it doesn't work like that for infectious diseases. So back it up a bit. This is the list of all the people. It's an interesting fact here. Only a third of these people are clinicians. These are all the people involved in treatment of Pauline Cafferty. A third of these people are doctors, nurses, infectious disease specialists. The thin end of the wedge is called in the military. You might have heard that. 2/3 of the people involved are support staff, cleaners, facilities management, porters. Turns out, there's a great quote from Michael Jacobs. If you imagine all the functions a hospital has to have, not only the clinicians, they all have to be involved. It turns out when you treat infectious diseases, when you try to do something, when you optimize for speed, for rate of change, you don't organize in these functional groups. You actually get everyone into one place. You create a capability and put everyone who needs to do or has an effect on treatment, in this case, into that one place. This is how we optimize for fast decision making, right? Agility. It's the idea of cross-functional teams with a single purpose focused entirely on patient outcome in the case of infectious diseases. Might sound familiar. Don't know. So it's interesting, right? Because this is some stats from a long-running ThoughtWorks project. We collected data over 18 months in Australia. Big program of work, there's about 100 people on this. Every time work leaves your team, goes somewhere else, it increases the length of time it takes you to complete a piece of work by an order of magnitude. I'll let that sink in. Every time you have to ask someone to do something for you, or a requirement goes to another team to have a little bit of work done on it, it increases the length of time by an order of magnitude. So this is from data. This is from data collected over 18 months. Cards that leave the team cycle, which is get done in 23 days. Cards that don't leave, on average, 2 days. That's the effect of work going outside your teams. That's why in Ebola treatment, work doesn't leave the team. Work stays within the team, because we want the 2 days. We don't want 23 days if you're treating Ebola. Similarly, with what we do, if we're optimizing for adaptability, for agility, for minimizing the cost of delay, maximizing the amount of money we can make, or saving lives, or whatever it is we're optimizing for, if we can get work done within teams, that's the way to go. And it's not just infectious diseases. My sister is a trauma nurse in ER. This is exactly what happens in trauma teams in ER. This is exactly what happens in Formula 1 teams. This is exactly what happens for the military these days. I think most of you have probably served in the military in Norway, have you? Do you still have that thing where you have to? Yeah, I mean, this is the NATO idea of a reinforced battle group. You have everything you need in one place. You don't have to have lots of different, the capabilities separated by time and space. Sounds as if this is all sort of coming together a bit. What does it look like for software then? So you've got this set of functional-based roles, silos. What happens if we merge some of these together into these cross-functional teams organized around these stable lines of business functions? That's the idea. So I was at an insurance company some years ago. It's called Compare the Market. In the UK, they're very famous because they have these meerkats, and they're everywhere on television. They have like Arnold Schwarzenegger doing adverts for them and all sorts of stuff. That's who it was. And they had this big monolithic application, big database, and they had all their different lines of business in the same application. So they had home insurance, pet insurance, etc., life insurance. And we recommended, for reasons, that they separate these things out into different lines of business, different capabilities. That's what they did. They separated these things out, took the data with it. They had these separate deployable applications in these separate lines of business. I'm not saying this was easy. It took a long time, right? It took I think they're still on the journey, and they started it in May 2011. So, when people say, "Can I have a quick fix for breaking up this big tangled piece of legacy software?" The answer is no. In my experience, it takes time. But we separated that into these lines of business and put cross-functional teams into these lines of business to develop software for them. And the nice thing here is we're starting to take advantage of this property, this Conway's law property. Right? So each of these lines of business, because we've got single teams focused on them, right, this team is not working on pet insurance, it's just working on home insurance. Naturally, over time, these teams, and therefore the software they're building, becomes decoupled. So we have cross-cutting concerns as well. So, this idea of cross-functional teams from Agile software development, it's very, very useful. It's how you get stuff done quickly. But also, sitting those cross-functional teams over long-lived, stable parts of your business reinforces Conway's law. Awesome. Melvin Conway's going, maybe they're starting to understand what I was talking about now, right? Okay. Can we go further though, right? Because we've reduced some of the chords, but not all of them. Can we go further? Because he's still really laughing at us. I think we can, right? We can play the continuous delivery card, right? DevOps, woo, that's Jez Humble, wrote continuous delivery with Dave Farley. We can say, yeah, cool, millennials, we'll do DevOps. Well, build it, run it, right? So we start to move some of the other capabilities we have internally, so some of the other roles we've got into those teams. This is what Amazon popularized with the you build it, you run it, and then fix it is the implied third bit on that, right? We start to say, okay, we've got this operations group who get software thrown over the fence to them. What happens if we start to bring those into our teams? And we have these build it, run it sort of teams. Well, again, we're removing these chords, we're removing cues from our system, improving our ability to get stuff done in a more rapid fashion. Nice. And then, each of these things you can deploy independently, build separately, tested separately, etc. So we've now got down to this, which is a lot better than it was. It's a lot better than this. But can we go further? Well, I think we can. Because Dr. Michael Jacobs said, all the functions a hospital has to have. He didn't say except for facilities and the porters. Right? All the functions. Well, what about the rest of our functions? I mean, some of these are stable and cross-cutting. What happens if we put our salespeople into these teams too? What happens if we put our marketing people into these teams? So have our marketing people who are responsible for marketing a product line actually is sitting with the product teams, with that product line. Again, improves the rate at which we get stuff done. You might have come across this as this idea. This is from Spotify. They talk about squads, chapters and guilds. It's a similar idea I'm talking about now. Right. I need to up the rate. I've only got 40 slides left. So this is what we talk about internally, is this idea of how you structure an organization almost in concentric circles. It's like an onion in some sense. So you have this, the organization on the outside. You then break it up into market segments, big chunks, right? markets. Maybe it's a set of customers are served by this particular market segment. This is where the art is. You then break those market segments up into value streams. Groups of teams delivering stuff for a particular value stream. You then break those value streams up into individual product-based teams, where each team owns one or more services. Coming back to the isomorphism with software development, with software architecture. And this is then isomorphic with your software architecture, as I say. So each of these teams are building services, or groups of components, or pieces of software. They are structured in a way that they are decoupled from one another. And as you grow out in terms of concentricity, each of those structures is also decoupled from one another. How big? Well, 10 to 20. This is XP, extreme programming style. 160 to 200 people. I won't ask the question, but this is Dunbar's number. How many social connections you can hold in your head. Greater than, the effect of this is if you've got more than 200 people or less than 200 people. If it's less than 200 people, it's the difference between saying, hey Kate, how are the kids? And I think I've seen this person before, but I've no idea who really they are. It's the kind of human aspect of relationships in work and multiples thereof. So these concentric structures built around these numbers. Where do you sit them? This is interesting. This is from a piece of research from Thomas Allen. So Thomas Allen did this in 1977. He's probably also sitting there laughing at us, right? But Thomas Allen found a very interesting fact looking at R&D departments and how information flowed in R&D departments. And this is what he found. Communication frequency with our colleagues varies with the inverse square of distance. And the effect is pretty amazing. So after about 8 meters, the chance that you're actually going to have a serendipitous conversation with a colleague is vanishingly small on a weekly basis. Right? So what this means is, if you don't like someone, sit them a long way away from you. But if you want people to talk, if you want people to communicate, this is the bandwidth thing again, sit them close together. And potentially have them work on the same things. Because Conway's law. This is why it's not a good idea to put a library next to the canteen or right in the middle of the canteen, right? You want the library a long way away so people can go and be quiet and have quiet time. Communication varies with the inverse square of distance. So this implies that we should co-locate as much as we can. Okay, so to take away, as you chunk up from team to value stream to market segment to organization, we can use these things to structure ourselves. Conway's law, Allen's research, Dunbar's number. And fundamentally, remember, whenever work leaves your team, you can incur cost, or you will incur cost. I promised at the start, there's this relationship, I think, between different things or properties of teams and software that we can use to reason about each of them. So I think, I need a better name for this. I'm not sure what it is. But this is actually open research at the moment. I was at an academic conference and people got very excited about this. I'm way too busy. I think that software system boundaries are isomorphic with team boundaries, and therefore you can use these two things, you can reason about each with respect to the other one, as long as you structure it in this sort of way. Right? So what does that mean? It means you can do different things with respect to testing, with respect to integration patterns, depending on where someone sits. That's an interesting idea. Right? You can shortcut some decision making, I think, depending on where people sit in relation to you, or which team they're in. So maybe between these sort of outer groupings or between organizations, you can apply certain patterns. I won't go into what the patterns are. You can look them up. Things like semantic versioning, we might want to implement on APIs between organizations or between market segments. But we might not bother doing contract testing, right? Because we might have lots of people using our API and we don't want all of them to write contracts for us. I don't want to submit a contract test for the Google Maps API, right? And Google don't want me to do that, right? But they do want to offer a stable versioned, semantic versioned API. Between value streams, we might want to do different things. We might want to use semantic versioning. We might also want to, implement contract tests. We might want to use the tolerant reader pattern. And within teams, we might not want to do these top two. We might want to rely on something called conversational change. hey Bob, I'm going to make a change to my bit of code, to my service. Do you mind just making a change to yours as well and we'll deploy them together? Without having to expend the time and therefore money on implementing all these things. So I've got a minute and a half left according to my slide. This is what ThoughtWorks does in this case, right? So stable functions, we've got some core services, etc. Thoughts to finish. It's not all about breaking stuff up into services, although that's part of it. How we organize ourselves is fundamental to how we build software and write software, and how we structure our teams to deliver that software is important. This is a quote from my colleague Evan, the inverse Conway manoeuvre. Design the organization you want and the architecture will follow, potentially kicking and screaming. I think we get signals from Conway's law. So every time we see one of these things, maybe that's a sign that our teams aren't structured optimally. And finally, there's a high cost associated with work leaving your team. Final last word. I got this email out of the blue. It's quite nice. Hello, James. I've recently come upon your presentations. Go faster. This is the previous version of this presentation. And how I finally stopped worrying and learned to love Conway's law. No, I'm not sitting on the balcony laughing. I'm sitting at my computer learning from you. And your depiction of me as a Muppets figure helps to keep me humble. Keep up the good work. That's from Melvin Conway. So this is the official stamp from Melvin Conway. That's all I got for you. Thanks very much.